Dear friends, good morning. You are welcome in my technical video channel. Today's we are discussing about the DC current, DC voltage and source of DC current. We are having mainly source of DC voltage are cells, primary cells and secondary cells. Primary cells are dry cells, they are not chargeable. Here you can see that their main source of DC current is source. DC current means the current that flows in only one direction. It is having constant voltage. When we apply a DC source to a load, there is a constant amount of current flows through the resistance. Here voltage is constant, current value is constant and depend upon the load resistance. There are mainly two types of cells, that is first primary cells and secondary cells. Primary cells are those cells which are not chargeable, whereas secondary cells are chargeable cells. The example of primary cells are dry cells, 1.5 volt dry cells, pencil cells, and secondary cells, the cells used in car batteries. These cells gives only 2 volt. For obtaining 12 volt, we have to connect 6 cells in series. So main function of cell is to supply DC voltages and it produce DC current. The main objective of understanding the DC current is to understand what is AC. In DC current only flows in one direction and it is generally having constant values that depends upon voltage and resistance. But in case of AC current, the value of voltage is continuously changing and it alternates in every cycle. In every cycle there is a positive half cycle and negative half cycle. Its voltage varies according to the sine function. So that is E is equal to E max sine omega t. That is the formula of AC voltage. It's having two cycles, positive half cycle and negative half cycle, that makes a complete cycle. Dear friends, in this circuit, this is a cell of 12 volt. This is resistance. If we switch on this button, then current I is equal to 12 volt upon 6 ohm. 12 volt upon 6 ohm is equal to 2 ampere. Here 12 volt is constant voltage, 6 ohm resistance is also constant and 2 ampere current is constant. We can draw a diagram like this graph. Here in this line, it is a time axis, 1 second, 2 second, 3 second, 4 second, 5 second, and it is current axis. Here we have drawn the current versus time. So the 2 ampere current is showing by this line. This current value is 2 ampere here at 0 second, 2 ampere at 1 second, 2 ampere at 2 second. Means the value of current is always 2 ampere irrespective of the time. Time is 1 second, 2 second, 3 second, but current is always 2 ampere. Time is 5 second, current is 2 ampere, 6 second, current is 2 ampere. Means for any value of time, the value of current is always constant, that is 2 ampere. Means the value of current only depends upon the resistance and the voltage. If we change the voltage, then value of current will change. But if we don't change voltage, then the current value is not changed. So it is DC. DC 12 volt means constant voltage. It is a resistance and the current flowing through this resistance is always constant, that is 2 ampere. If we change the value of resistance or voltage, then the value of current will change. So it is DC current. Means current is always constant irrespective of time, from 0 second to infinite time, where up to the switch is switch on. The current value is constant. But in case of AC, the value of voltage is changes continuously with time. This is time axis, this is voltage axis. So here value is 0. Gradually as time is increases, value increases and it goes to the maximum value of Emax, then voltage decreases to 0. Again voltage increases in negative direction and then voltage goes to the 0. So here it is equal to time, it is equal to degree. Means one positive half cycle and one negative half cycle is made a complete cycle, that is equal to 360 degree. And as per the frequency of this voltage, this time required is can be find out. The capital T is denoted the time for one cycle. Here in our supply system, the frequency is 50 Hz. In that case, time period is 20 milliseconds. So from this point to this point, for 360 degree, our supply system frequency takes 20 milliseconds for one cycle. Means 10 milliseconds for positive half cycle and 10 milliseconds for negative half cycle. Total 20 milliseconds. So in say 1 second there are 1000 milliseconds. So we get the frequency of our supply system is 50 Hz. If frequency goes to 100 Hz, then this time period becomes 10 milliseconds. So the frequency of AC supply system is very important for finding out the time period and for calculating many parameters of AC circuit. So this frequency part is very important, and this is why it is alternating, because one half is positive and second half is negative, third half is positive, fourth half is negative. So it is known as alternating, means once positive, again negative, again positive, again negative, that is alternating current. So when we apply this alternating voltage to any load, then there is current flowing, that is alternating current. So I think it is clear to you. Main sources of AC voltage are there. First is small generators used in decoration purpose. These generators generally having 2 to 5 kilowatts capacity, and some higher capacity generators are used in home, that is 15 kV generators used in very big buildings like hospitals and hotels. Then some small alternators are used in car and automobile circuits. They give 12 volt supply for charging a battery of cars and truck, etc. Then main source of AC supplies, big power stations, thermal power plants, nuclear power plants. They are having very big capacities, alternators, 500 megawatt, 250 megawatt and 1000 megawatt, etc. These alternators produce voltage at 11 kV. These voltages are then step up to 400 kV volt or 220 kV voltage, and then goes to different cities. There it is step down, and then they give 230 volt and 400 volt supply to the domestic purpose. So this is the basic idea how we will get AC voltage. And in our home, the AC supply voltage is normal 230 volt 50 Hz supply. It is single phase supply, and in 3 phase supply 440 volt 3 phase supply 50 Hz. 50 Hz is our frequency. Its value is constant 50 Hz, but it may decrease to 49 Hz sometimes, but 49 to 50 Hz is the normal value of frequency. So it is, I think, very clear to you. And in next session we will discuss about the AC current through inductor and effect of electric current and magnetic effect of electric current. Thank you very much.